Good morning, ma. A very good morning, everybody. We will wait for one more minute. At 10 o'clock, 2 minutes, we will start the session. Okay. Students, am I audible? Is my audio clear? A very good morning. Is my audio clear? Okay, fine. Fine, thank you. Okay, a very good morning to everyone. Let's get started. You know that I'm Susar Andal, working as assistant professor in our department. I'm going to handle the GATE paper, electrical and electronic measurements. You have 9 subjects in GATE, and one of the subject is electrical and electronic measurements. I am going to handle you the questions from this electrical and electronic measurements topic. Okay, this electrical and electronic measurements area of GATE paper is a very simple. If you know the basics of electrical engineering, then it is easy for you to get the score. The weightage given to this paper, electrical and electronic measurement papers, the weightage given to this electrical and electronic measurements is 5 marks. Almost 10% of weightage will be given to this. 5 marks will be given to this topic, electrical and electronic measurements. This is a very simple area which we can get easy. We can score mark easily in this area. Keep that in mind. If you concentrate, if you give a little bit of concentration to this paper, definitely it is easy for you to score the marks in this paper. I will assure you the 5 marks. If the 5 marks is given to this paper, I will assure you at the end of the GATE session of this, it will go 3 or 4 sessions, electrical and electronic measurements. If 5 marks of the questions asked from this electrical and electronics measurement, definitely you can get 4 marks. 80% of the questions will be covered in this, I assure you. So please make use of this session. Is my audio clear? Can you follow me? I need the response, ma. Is my audio clear? Can you follow me? Yes, I am going to handle this electrical and electronic measurements paper. This is a very simple topic. In the from all the 9 papers, this is the only simple topic. You can score good marks in this electrical and electronic measurement without giving much effort. Without taking much effort, you can score a good marks in this electrical and electronic measurement. I'm going to handle this electrical and electronic measurement. I'm going to handle all the 1 mark and 2 marks in this possible 1 marks and 2 marks GATE questions in this paper. If you follow my classes clearly, if you keenly observe the classes, definitely you will score the 80% of the GATE marks, GATE score in the particular topic, electrical and electronic measurements. Okay, this electrical and electronic measurements, what are the syllabus? What is the syllabus for this electrical and electronic measurements? What is the syllabus? These are the topics we have to cover. These are the topics we are going to study in the heading of electrical and electronic measurements. Already you people studied measurements and instrumentation paper, right? In the 4th semester, you have studied measurements and instrumentation, right? Have you studied? All of you studied this measurements and instrumentation paper in 4th semester, right? Have you studied? Say yes or no. No response from your side. Gate class must be interactive session, right? The gate coaching class must be interactive. You people are not even answering in the chat box. You are not unmuting yourself, so that's not the problem. At least you can give your answers. You give your response in chat box, na? Yes. You have studied the measurements and instrumentation paper, electric circuits. Those are the basics for this electrical and electronic measurements. This is just a electrical and electronic measurements. The major topics covered in this syllabus is from electric circuits as well as M&I, measurements and instrumentation only. In the electric circuit, we know the basics of wattmeter, voltage, current, how the power is measured, how the power factor is calculated. Those things you have studied in the paper electric circuits. In the measurements and instrumentation paper, you have studied bridges. You have studied Maxwell's bridge, Wheatstone bridge. Those things you have studied. So bridges, potentiometers, and what are the PMMC instrument, moving ion, moving coil instruments, instrument transformers, what is analog voltmeter, digital voltmeter, what is the purpose of multimeter, how a multimeter is used, how a digital voltmeter is used, and how the phase time oscilloscope, CRO, DSO, digital storage oscilloscope, what are the error of these meters, oscilloscopes, the time and frequency measurement. Those things you have studied in M&I paper as well as in the electric circuits paper, right? That is what we are going to analyze in this electrical and electronic measurements gate questions. Okay, I'm classifying this electrical and electronics measurement gate questions I'm dividing this into two categories: 1 mark questions and 2 mark questions. Okay, the gate questions are will be of 1 mark as well as 2 mark. Both 1 and 2 marks will be if it is directly we can answer na, that will be treated as 1 mark. We have to get a procedure, we have to solve it for more than 1 minute, in the sense that will be treated as a 2 mark. You know that you know all the basics about gate exam pattern. For the past 2 months you are going through gate coaching, right? So I know, I hope you have clear idea better than me in the gate coaching classes, right? So the same way, I am going to handle you the mixture of 1 mark as well as 2 mark question. I will divide it into 1 mark and 2 mark. You have to classify that as a whether this will be a 1 mark or 2 mark that you are going to classify, depending on the questions and the procedure time to take the time to get the solution. Okay. Shall we go to the question section? Shall I move to the next question session? Shall I start to solve the questions? As I already said, you have to respond, Mima. You have to respond me. Are you following? These are the topics in under electrical and electronic measurements, bridges and potentiometers, measurement of voltage, current, power, energy and power factor, instrument transformers, digital voltmeters and multimeters, phase, time and frequency measurements, oscilloscopes and error analysis. These are the topics that we have to cover in the heading of in the syllabus of electrical and electronic measurements for gate preparation. The electric circuits paper and measurements and instrumentation paper are the two basic papers which we need to clear this electrical and electronic measurements. The basics of electric circuits will be applied in this electrical and electronic measurements. We know in the electrical circuits paper, we have studied how the voltage, current, power and energy is calculated in a particular circuit, how the voltmeter is used, how the multimeter is used, and the use of oscilloscope. Those things we have studied in M&I as well as electric circuits. The gate questions will be of 1 mark as well as of 2 mark. We are going to solve the gate questions from the topic of electrical and electronic measurements one by one. Shall I move to question session? Shall I move to question session? Can you get the idea what I am going to teach? Are you following me? Can you get my point? Can you understand what I am going to teach? I need the response, ma. Yes. Okay, thank you. So I am going to handle the problem associated with all the topics in the electrical and electronic measurement. I am moving on to the first question. This is the first question. This is a simple question that you can get the answer in 1 or 2 minutes. I am reading the question. You have to observe the question, try to answer it. Otherwise, if you try to answer, then you can answer, or I will let you know the answers. Okay? Will you try? Will you try? Will you try it? I am reading the question. Is my screen clearly visible? Is my screen visible clearly? Okay. I'm going to read this question. Try to answer these questions. Okay. 3 moving ion type voltmeters. 3 moving ion type voltmeters are connected as shown below. Voltmeter readings are V, V1 and V2 as indicated. The correct relation among the voltmeter reading is this is one of the basic question you can answer within the 2 minutes of questions. Within 1 second, 1 or 2 seconds you can answer. Will you try? 3 moving ion type voltmeters are connected as shown below. Voltmeter readings are V, V1 and V2 as indicated. The correct relation among the voltmeter reading is, what is the answer? Option A. This is a circuit shown in figure. 3 voltmeter connected. This is the voltmeter 1 reads V. This is the voltmeter 2 reads the voltage of V1. This is the voltmeter 3 reads the voltage of V2. They are asking what is the correct relation among the voltmeter reading. Option A, V is equal to V1 by root 2 plus V2 by root 2. Option B, V is equal to V1 plus V2. Option C, V is equal to V1 V2. Option D, V is equal to V2 minus V1. Will you try? Can anyone say how can we get the relation between the voltmeter? Any law to get the voltmeter reading? Is there any law to get the voltmeter reading? Relation between voltmeter reading? Is there any law? Just try it, ma. Respond பண்ணுங்க உனக்கு ஏதாவது நீ தப்பா சொன்னாலும் அது ஒன்றும் இல்லை. I will try to correct it. அவ்வளவுதான். Just try it, ma. Just try it. Is there any law to get the correlation, get the correct relation between voltmeter readings? This is a simple question. 3 voltmeters are connected. We have to get the correct relation among the voltmeter readings. Yes, very good, Mohammed Mohidin. Very good, ma. We can apply Kirchhoff's voltage law. Very good. We can apply Kirchhoff's voltage law. By applying Kirchhoff's voltage law, what is the correlation I will get? What is the relation I will get? Option B. Yes. Option B. We know that according to Kirchhoff's voltage law, we know that what is Kirchhoff's voltage law? Can anyone say the statement of Kirchhoff's voltage law? Can anyone tell me the statement of Kirchhoff's voltage law? Unmute your mic and say the answer, ma. Unmute your mic and say the answer. Statement of Kirchhoff's voltage law. Unmute your mic and say the answer, ma. 39 people are present in the GATE coaching class, but no one is responding. I am asking such a basic question from electrical engineering. A very basic question. Statement of Kirchhoff's law only I am asking. But you people are not responding. Just try it, ma. Try it. Okay, I will make it as a slideshow. Is that okay now? Bharat, is that okay now? Yes, okay, fine. So, Kirchhoff's voltage law statement, can anyone tell me? We know that Kirchhoff's voltage law states that algebraic sum of voltages around any closed path is equal to 0, or sum of voltage rise equal to sum of voltage drop in a closed circuit. We can say sum of voltage rise equal to sum of voltage drop in a closed circuit. Sum of voltage rise is equal to sum of voltage drop in a closed circuit, or I can say algebraic sum of voltages around any closed path is equal to 0. So, to get the correct relation among the voltmeter reading, I am applying basic Kirchhoff's voltage law. According to Kirchhoff's voltage law, we know that algebraic sum of voltages around any closed path is equal to 0. So, this V is a supply voltage. I am taking this as a supply voltage. These two will be treated as a drop because these are the impedances. These are the impedances. So, I am taking this as a drop. This supply voltage. So, I can take sum of voltage rise equal to sum of voltage drop. The voltage rise is V. The voltage drop is, the voltage rise is V, the voltage drop is V1 and V2. So we know that sum of voltage rise equal to voltage drop. Automatically the answer will be, the option, answer the option B. Is everybody understood? Is everyone understood this? Students, respond me, ma. Is everyone understood this problem? This is a simple problem in which I have applied Kirchhoff's voltage law. Okay. I have applied Kirchhoff's voltage law to get the correct relation among voltmeter reading. It is a closed circuit. So to get the relation between voltage in a closed circuit, okay. So to get the correct relation among the voltmeter readings, I am applying just KVL. KVL, we know that sum of voltage rise equal to sum of voltage drop. The voltage drop is across the impedances. So V1 and V2 will be treated as a drop. This V will be treated as a voltage rise. So sum of voltage rise equal to sum of voltage drop. So automatically the answer will be option B. Okay. This is the answer. The next one. Shall I move to next question? Is this understood? Respond, ma. Shall I move to next question? Yes, fine. The next question. See, the input impedance of the permanent magnet moving coil PMMC voltmeter is infinite. The input impedance of the permanent magnet moving coil voltmeter is infinite. Assuming that the diode shown in the figure below is ideal diode. Assuming that the diode shown in the figure below is ideal circuit, the reading of the voltmeter in the volts. We have to get the reading of the voltmeter. Okay. The question is the input impedance of the permanent magnet moving coil voltmeter. The input impedance of the PMMC voltmeter is infinite. Assuming that the diode shown in the figure below is ideal, the reading of the voltmeter in volts. Can anyone say the answer? How can anyone say the procedure to solve this question? How can we solve this question? We know that this is the supply voltage. The supply voltage is here. The supply is DC or AC? The supply is DC or AC? It's a AC supply. It's a AC supply. The diode here is ideal diode. As they said, the diode here is ideal diode. We have to get the voltmeter reading. How to get the answer for this question? What is the answer? Can anyone say? What is the answer? Or can anyone say the method to solve this? This is the input voltage is AC voltage, right? The input voltage is AC voltage. So it has both positive and it has both positive as well as negative half cycle. Okay. During positive half cycle, the diode forward biased or reverse biased. During positive half cycle, the diode will be forward biased or reverse biased. During positive half cycle, the diode will be forward biased or reverse biased, ma? Yes, during positive half cycle, this is also, this terminal is positive, this one is negative. During positive half cycle of the input voltage, the diode is forward bias. If the diode is forward bias, in the sense it can conduct or it cannot conduct. During forward bias condition, the diode can conduct or cannot conduct. During forward bias condition, the diode can conduct or cannot. During forward bias condition, the diode can conduct. So during forward bias condition, this diode can conduct, so it will act as a short circuit. It will act as a short circuit. During the positive half cycle of the voltage, the diode is forward bias, so it can conduct, it acts as a short circuit. If it is short circuited, what is the reading in the voltmeter? If this is short circuited, what is the reading in the voltmeter? During positive half cycle, the diode is forward bias because it's the ideal diode, it is forward bias. Yes, very good, it is 0. During Positive half cycle, the diode is forward biased and it is short circuited. It acts as a short circuited, so it can conduct, the voltmeter reading will be a 0. The voltmeter reading will be 0 during positive half cycle. During negative half cycle, what will happen? During negative half cycle, the diode will be, during negative half cycle, the diode will be, during negative half cycle, the diode will be reverse bias, so it will not conduct. So it will act as a short circuit or open circuit. It will, during positive, it will act as a short circuit. During negative half cycle, it will act as a open circuit. During negative half cycle, it will act as a open circuit. It will act as a open circuit. So in the open circuit condition, the current will not flow through this. The current will flow through a 100 kilo ohm. So the circuit will be of like this, right? Here a supply voltage, here a supply voltage, and here 1 kilo ohm resistor, and this will be a 100 kilo ohm resistor. This will be a circuit during negative half cycle, right? Right? This is 1K and this will be a 100K. Now what is the volt, how we can find the voltmeter reading? Now how can we find the voltmeter reading? Using voltage division rule. Using voltage division rule, we can find the voltage across this voltmeter. According to voltage division rule, the voltage is total voltage. We have to find the voltage across 100K, right? We have to find the voltage across 100K, that is the voltmeter reading. Am I right? Am I right? Students, are you following me? Are you following me? Are you following me or not? No response from you people. Are you following? So, okay. To find the voltage across 100. Oh, is my voice breaking? Okay, ma, I will try to hold it. Is it clear now? I'm adjusting my headphones. Is it clear now? Bharat, is it clear now? Bharat? Ma, is my audio clear now? Or still it has some disturbances? Just respond, ma. Is it clear now? Okay, fine, fine. So to find the voltage across, 100 kilo ohm, I'm just applying the voltage division rule. I'm just applying the voltage division rule. We know that according to voltage division rule, the voltage across particular resistor is the source voltage into same resistor divided by total resistor. Total resistance 100 plus 1, 1K, 100 and 1K. So the same way it is solved here. The answer is option A. What is option A? What is the value of option A? 4.46 volt. 4.46 volt. How can I get this? I'm just applying the AC voltage. The AC voltage has both positive and negative side half cycle of the voltage. One cycle has positive half cycle and negative half cycle. So during the positive half cycle, the diode is forward biased, so it can conduct, it acts as a short circuit. It is a short circuit condition, so automatically the voltmeter reading will be 0 during the positive half cycle. During the negative half cycle of the voltage, the diode is reverse biased, so it cannot conduct. So the current will flow through a 100 kilo ohm resistor. So the circuit will become like this. During negative half cycle, the circuit will become like this. So I will get the circuit V is equal to V 1K 100K ohm. So the voltmeter reading is nothing but the voltage across, because the voltmeter is connected across 100 kilo ohm resistor. The voltmeter is connected across 100 kilo ohm resistor. So voltmeter reading is nothing but a voltage across 100 k ohm. The voltage across 100 kilo ohm is taken as the voltage across 100 kilo ohm is taken as the voltmeter reading. So to find the voltage across 100k, I am using the voltage division rule. So from the voltage division rule, I am getting the answer. The answer for the voltage is 14.14. 14.14. The value is 14.14. The RMS value here the RMS value is, we know that Vm by root 2. So V2 RMS is V2 by root 2. This value is equal to 14. During positive half cycle, the reading is 0 volt. During negative half cycle, it will be of 14 by root 2. The total voltage, the total average voltage for the whole period. The total average voltage for the whole period is V1 plus V2 RMS, average of 2. V1 plus V2 RMS by 2. V1 value is equal to 0 during positive half cycle. The V2 value will be 14 by root 2 divided by 2. By substituting this value, the answer is 4.94. It is approximately the relatable answer is 4.46. So the option A is the answer. Is this clear? Is this clear, ma? Can you get the procedure of how to solve this question? Can you understand how to solve this? Say yes or no. Can you understand how to solve this question? Just respond, ma. Just respond. Shall I move to next question? Is this clear? Is that clear? Shall I move to next question? Okay, I'm moving to the next question. The next question is, two magnetically uncoupled inductive coils. Two magnetically uncoupled inductive coils have quality factors, Q factors, Q1 and Q2 at the chosen operating frequency. Two magnetically uncoupled inductive coils have Q factors, Q1 and Q2 at the chosen operating frequency. Their respective resistance are R1 and R2. When connected in series, their effective quality factor at the same operating frequency is, what is the value of the effective quality factor when they are connected in series? That is the question here. Is question clear? Is question clear? Is question clear? Two magnetically uncoupled inductive coils. Two magnetically uncoupled inductive coils have quality factors Q1 and Q2 at the chosen operating frequency. Their respective resistance are R1 and R2. When connected in series, what is the value of effective quality factor at the same operating frequency? What is the formula for quality factor? What's the formula for quality factor in the inductive circuit? What's the formula for quality factor in the inductive circuit? Q is equal to, what's the value of quality factor? Are you following me? Are you people are listening? Are you people listening? Am I understandable, ma? Just let me know, am I understandable? Am I audible? If no response from your side now, how can I take this? Okay, it's clear. Thank you, Jayalakshmi, for the response. The quality factor. We have to find the quality factor, total quality factor, that is the effective quality factor when the two magnetically coupled circuit, uncoupled circuits are connected in series. In the inductive circuit, what is the value of quality factor? We know the value for quality factor equal to XL by R. In the capacitive circuit, we can say it as a XC by R. XL by R or XC by R. In a RLC circuit, we can say it as a XL or XC by R. Here it is a inductive coils. So it is an inductive coil. So the quality factor value Q value will be of XL by R. The Q value will be XL by R. XL by R. So XL can be written as omega L by R. XL can be written as omega L by R. XL can be written as omega L by R. So the answer, the quality factor of first coil, the quality factor of first coil is Q1 equal to omega L1 by R1. The quality factor of second coil will be taken as Q2 is equal to omega L2 by R2. We know from the electric circuits, from the series resonance and RLC circuit, we know the formula for quality factor. Quality factor equal to XL or XC by R. Here it is an inductive circuit. Here it is an inductive circuit. So quality factor value will be a Q is equal to XL by R. The XL can be written as omega L. So Q1 can be written as omega L1 by R1. Q2 can be written as omega L2 by R2. So in a series circuit, it is a combination of both two uncoupled circuits, L1 and L2. So the effective quality factor Q is equal to XL divided by R equivalent. XL equivalent divided by R equivalent. XL equivalent value is nothing but sum of two inductances, omega L1 plus omega L2. R equivalent is sum of two resistances, R1 plus R2. So the effective quality factor Q is equal to omega L1 plus omega L2 divided by R1 plus R2. But in the answer, in the options, the answers are in terms of quality factor, not in terms of inductance. Keep this in mind. In the options, the answers are in terms of quality factor, not in terms of inductance. Here, the quality factor in this step, the quality factor is in terms of inductance. So to convert this inductance in terms of quality factor, I am dividing the numerator and denominator by R1, R2. I am dividing both numerator and denominator by R1, R2. By simplifying this, I am getting this answer, Q1 R1 plus Q2 R2 divided by R1 plus R2. This is option C. This is option C. So the answer for this question is option C. Is it clear? Is it clear? How can we get this? Can you understand? வேற ஒவ்வொரு கொஸ்டின் முடிச்ச உடனே நீ புரிஞ்சுதுன்னு எனக்கு ஏதாவது ரெஸ்பான்ஸ் கொடுத்தேனாதான் எனக்கு நெக்ஸ்ட் கொஸ்டின் போக ஈஸியா இருக்கும். இல்லாட்டி இதுவே கிளியர் இல்லாம இருக்கும்னு எனக்கு ஒரு மிஸ் அண்டர்ஸ்டாண்டிங் இருந்துகிட்டே இருக்கும். Is it clear? Is that clear? Yes, fine. This is a simple logic. I am applying the knowledge of basic electric circuit as well as measurement techniques only. I am not going through any tedious topics. This is, you can get the good score from the electrical and electronics measurement. Okay. The next question. See? See, the next question is a periodic voltage waveform. A periodic voltage waveform. A periodic voltage waveform observed on an oscilloscope across the load is shown in figure. A periodic voltage waveform observed on an oscilloscope across the load is shown in figure. A PMMC, permanent magnet moving coil meter, is connected across the same load, reads the output voltages shown in figure. Okay. A periodic voltage waveform observed on an oscilloscope across the load is shown in figure. The permanent magnet moving coil meter connected across the same load reads the voltage is shown in figure. We have to get the voltage, total voltage. How can we calculate? Can anyone say? The total time is the total time is in the output of, in the variable output with respect to load output, the formula for output voltage is, the formula for output voltage is, to find the total voltage, the formula for output voltage is 1 by T integral of 0 to T 0 to T இப்படி ஒரு ஃபார்முலா படிச்சிருக்கியா? இப்படி ஒரு ஃபார்முலா படிச்சிருக்கியா? பவர் எலக்ட்ரானிக்ஸ்ல படிச்சிருப்ப இந்த மாதிரி ஃபார்முலாஸ். அனலாக் எலக்ட்ரானிக் சர்க்யூட்ஸ்ல படிச்சிருப்ப. Have you studied any formula like this? P is equal to 1 by T integral of 0 to T V of T dt. V of T dt. V is equal to 1 by T integral of 0 to T V of T dt. What's the T? T is nothing but total time. What's the total time here? What's the total time here? What's the total time here? Yes, total time is 20 millisecond. So during 0 to 10 millisecond, during 0 to 10 millisecond, the V of T, during 0 to 10 millisecond, the V of T varies with respect to time. It is a ramp signal. It varies with respect to time. During 10 to 12 seconds, 12 millisecond, 10 to 12 millisecond, the V of T value is, during 10 to 12 millisecond, the V of T value is, during 10 to 12 millisecond, the V of T value will be, the V of T value will be 10 to 12 millisecond, the V of T value will be -5. During 12 to 20, During 12 to 20, it is 5. So we can give this, we can split this limitations into, how can we can put this, V is equal to 1 by T. The time, total time is 20 milliseconds. So in the place of T, I can put 20 millisecond. This 0 to T V of T into divided into 3 limits. First limit is from 0 to 10 V of T dt, plus second 10 to 12 V of T dt. Third integration 12 to 20 V of T dt, like this. So 1 by T integral 0 to T V of T dt. The total time is 20 milliseconds. So 1 by 20 millisecond, 20 into 10 power minus 3, 0 to 20 V of T dt. This 0 to 20 is divided into 3 categories. First is 0 to 10. The second one is 10 to 12. The third limit is from 12 to 20. During 0 to 10, the voltage varies with respect to the time. So I am taking this as a T dt. It varies with respect to time. So I am taking this as a T dt. During 10 to 12, V of T value is minus 5. During 12 to 20, the V of T value is plus 5. I am integrating this. So integrating T dt, I will get T square by 2. I know that. Minus 5. Integration of dt, I will get T. The same way here also, integration of dt, I will get T. The upper limit 20, lower limit 10. Here upper limit 20, lower limit 12. By substituting the limit value, by solving this, I can get 4 voltage. So the PMMC meter connected across the same load will read a voltage of 4 volt. Will read a voltage of 4 volt. Now can you get my point? Can you understand how to solve this problem? Is that clear? Is that clear? Is that clear? Say yes or no. Is this clear? Can you get how to solve this problem? Can you get this point? Say yes or no. Shall I move to next question? Shall I move to next question? Okay, I'm moving. The next one is, this is a simple question. Within the second we can answer for this. Answer is given in the question itself. The bridge method commonly used for finding mutual inductance. The bridge method commonly used for finding mutual inductance. The bridge method commonly used to find a mutual inductance is Heaviside Campbell bridge. Option A is the answer. The Heaviside Campbell bridge is used to find the mutual inductance. Here the mutual inductance can be calculated in terms of self-inductance. Mutual inductance can be measured in terms of self-inductance using Heaviside Campbell bridge. Okay, Heaviside Campbell bridge, that is the answer. The bridge method commonly used to find the mutual inductance. Okay, the next one. The next question. For the circuit shown in figure, the voltage and current expressions are V of t equal to E1 sin omega t plus E3 sin 3 omega t, and current I of t equal to I1 sin omega t minus phi 1 plus I3 sin 3 omega t minus phi 3 plus I5 sin 5 omega t. V of t equal to E1 sin omega t plus E3 sin 3 omega t, and I of t equal to I1 sin omega t minus pi 1 plus I3 sin 3 omega t minus pi 3 plus I5 sin 5 omega t. The average power measured by the wattmeter. Voltage and current value given here. What is the value of power? The question is, what is the value of power? What is the formula for power? What is the formula for power? What is the formula for power in terms of voltage and current? What's yes, power value is P is equal to VI. P is equal to VI. Yes, P is equal to VI. So from the question, the value of V is V of t equal to E1. I am taking omega t as a theta. I am taking omega t value as a general term theta. So V of t is equal to E1 sin theta plus E3 sin theta. I of t value is equal to I1 sin theta minus phi 1 plus I3 sin 3 theta by pi 3 minus I5 sin phi theta. In the AC circuit, we can easily say the power value will be P is equal to VI. But in DC circuit, we can directly say power value P is equal to VI. But in AC circuit, the power value P is equal to, the value of power will be equal to P is equal to 1 by 2 pi integration 0 to 2 pi V of t into I of t d theta. Okay. By substituting the value of V of t and I of t and using the mathematical formulas, the answer for this question will be option C. P is equal to 1 by 2 E1 I1 cos pi. We have to solve this. Okay. To solve the formula, we are to solve the question, we are having this formulas. The formula is given here. Okay. Okay. Say yes or no. Is this problem understandable? Am I understandable? Is my class understandable, ma? Is my teaching understandable? Is my teaching understandable, ma? Say yes or no. No one is listening, ah. Nobody is listening, ah. Is my teaching understandable, ma? Nobody is listening. Is my teaching understandable? Yes, fine. Fine. Just applying the formula, I will get the solution. The answer is option C for this question. Option C, which is 1 by 2 into E1 I1 cos pi 1 plus E3 I3 cos pi 3. Okay, fine. The next question. I am moving on to the next question. An analog voltmeter. An analog voltmeter uses external multiplier settings. An analog voltmeter uses a external multiplier settings. With a multiplier setting of 20 kilo ohm, it reads a voltage of 440 volt. With a multiplier setting of 80 kilo ohm, it reads a voltage of 352 volt. For a multiplier setting of 40 kilo ohm, the voltmeter reads, what is the value? What is the value? An analog voltmeter uses an external multiplier circuit. With a multiplier setting of 20 kilo ohm, it reads 440 volt. With a multiplier setting of 80 kilo ohm, it reads 352 volt. For a multiplier setting of 40 kilo ohm, the voltmeter reads. See, always the answer is between these two. If 20 kilo ohm, the voltage is 440 volt. If 80 kilo ohm, the voltage is 350 volt. So the answer is in between 440 and 352 volt. If the answers, if in the options, if the answer is out of this two values, not in between 352 or 440, you can neglect the answer. But in the option, all the four answers are in between 352 and 440 volt. So no other go, we have to solve the answer. If the answers are, if the options are beyond this voltage range, 352 and 440 volt, if beyond this range, then you can neglect those options. You can find out the answer easily. Okay. But in this question, all the options are within the limit, within 350 to 440. So no other go. We have to solve the questions. We are having the multiplier circuit. This is the multiplier circuit. This is the analog voltmeter. The analog voltmeter, this is the multiplier circuit used. The analog multiplier uses the external multiplier circuit. If this multiplier value is 20 kilo ohm, the voltage is 440. If the multiplier value is 80 kilo ohm, then the voltage is 352 volt. If the multiplier value is 40k, what will be the voltmeter reading? That is the question here. So I am having this. This is the IM is the current of the voltmeter. Fully scale deflection current of the meter. This RM is the internal resistance of the. This is the internal resistance of the meter. RS is nothing but the multiplier resistance value. This is the voltage across this. So I am having the answer. We know the voltage formula for voltage is V is equal to IR. According to Ohm's law, we know V is equal to IR. So the V is equal to the total V. This total V is equal to IM. The current flowing through this is same current IM, because this internal resistance and the multiplier resistance are connected in series or parallel. Internal resistance and multiplier resistance are connected in series or parallel. Internal resistance and multiplier resistance are connected in series. So the total voltage, this V, this total voltage V is equal to I into Rm plus Rs. I into Rm plus Rs. So I am dividing this by both the sides by Rm. Okay. So V by Rm equal to, I will get Im into Rm plus Rs by Rm. Rm plus Rs by Rm. Bringing this Im in the left hand side of the equation. Bringing Im to the left hand side of the equation, the Im value will be come at the denominator of this. So Im Rm will be written as a Vm. So the equation will be V divided by Vm equal to Rm plus Rs. V divided by Vm equal to Rm plus Rs divided by Rm. Rm value is the internal resistance value. Rm is nothing but internal resistance value. So Rm by Rm plus Rs by Rm. Rm plus Rs by Rm equal to 1 plus Rs by Rm. It is equal to 1 plus Rs by Rm. We know that when Rs value is equal to 20 kilo ohm, when this multiplier resistance Rs value, when this multiplier resistance value Rs value is equal to 20 kilo ohm, the Vm value is 440 volt. When this Rs value is equal to 80 kilo ohm, the Vm value is 52 volt. Substituting these two values, I will get V divided by 440 volt equal to 1 plus 20k divided by Rm. V divided by 352 equal to 1 plus 80k divided by Rm. So here I am having two equations, equation 1 and equation 2. By solving equation 1 and 2, the V value is 480 volt and Rm value is 220 kilo ohm. Now we have the value of V, Rm, and the Rs value given is, the third Rs value given is 40 kilo ohm. By substituting all the values, V is equal to 480 volt, Rm value is 220 kilo ohm, and Rs3 value is equal to 40 kilo ohm. By substituting all the values in this equation, I will get the value of V. The V value obtained is 406 volt. So the answer is option D. Option D. The V value obtained using the solving the equation is 406 volt. This is the answer. This is the problem. This is how we are solving this problem. Can you understand? Can you understand this? Can you understand how to get this answer? Can you understand, ma? Can you understand how to get this answer, ma? Just respond. Satish? Satish? Bashit, is this clear? Bharat? Mohideen? Okay. I am moving on to the next question. Thank you. I am moving on to next question. Moving to a dual trace oscilloscope. A dual trace oscilloscope is said to operate in the alternate mode. A dual trace oscilloscope is said to operate in the alternate mode. The control input of the multiplexer used in the Y circuit is fed with the signal having a frequency equal to the control input of the multiplexer used in the Y circuit is fed with the signal having a frequency equal to option A, the highest frequency that the multiplexer can operate properly. The highest frequency that the multiplexer can operate properly. Option B, twice the frequency of the time-based oscillator. Twice the frequency of the time-based oscillator. Option C, the frequency of the time-based oscillator. Option B, the frequency of the time-based oscillator. Option D, half of the frequency of the time-based oscillator. If this is the considerations, the following statement, you have to consider the following statements. Number one, the compensating coil of the low power factor wattmeter compensates the effect of the impedance of the current coil. Option B, the compensating coil of the low power factor wattmeter compensates the effect of impedance of the voltage coil circuit. If these are the considerations, find the answer. What is the answer? If option A, first statement is true, second is false. Option B, first statement is false, but second is true. Option C, both 1 and 2 are true. Option D, both 1 and 2 are false. A dual trace oscilloscope has the following considerations with respect to frequency of the signal. The one is the highest frequency that the multiplexer can operate properly. The second one is twice of the frequency of time-based oscillator. The third one is the frequency of the time-based oscillator. The fourth one is half of the frequency of the time-based oscillator. Okay. If the considerations are given as here, what is the solution? Whether it can compensate the impedance effect of the current coil or it will compensate the impedance effect of the voltage coil of the low power factor circuit. Usually it is a rule. Okay, it is a rule. How the voltage law is ruled, how the Ohm's law is ruled. It is a law. In the same way, Always the low power factor wattmeter always compensate the impedance of a current coil, not a voltage coil. So the answer is, it always compensates the effect of the current coil. So the answer will be, so the answer will be, so the answer will be, so the answer will be option A. Always it compensates the coil of a low power factor wattmeter impedance of the current. This is the option here. Okay. I am moving on to the next question. The next question, the bridge circuit shown in the figure below is used for the measurement of the unknown element ZX. The bridge circuit shown in the figure below is used for the measurement of an unknown element ZX. The bridge circuit is best suited. The bridge circuit is best suited when the ZX is a, when the ZX is a, this is simple logic. You can tell the answer immediately. The simple logic is employed in the circuit. You can answer immediately. If I have to balance the circuit, what is the value of ZX? If I want to balance this circuit, bridge circuit, what is the value of ZX? Options are low resistance, option B high resistance, option C low quality factor inductor, option D lossy capacitor. You can answer within a second. Just try it, ma. Just try it. What's the bridge circuit? Is this Wayne bridge or Wheatstone bridge or Maxwell's bridge? What's the bridge circuit implied in this? It's the Maxwell circuit. It's the Maxwell circuit. If you are considering this as a Maxwell circuit, what will be the value of ZX? Consider this as a Maxwell bridge circuit. What is the value of ZX? Options are given here. Low resistance, option A, option B, high resistance, option C, low quality factor. Yes, very good question. It's the option C. Because to compensate the effect of capacity, the opposite side must be a, to compensate the effect of capacitance, the opposite compensation must be a inductor. Yes, answer is option C. Very good. Low quality factor inductor, option C. Consider this as a Maxwell circuit. Answer is good, very good question. So consider this as a bridge circuit of Maxwell bridge circuit. In this Maxwell bridge circuit, we are having this bridge circuit compensation balancing for balancing the bridge circuit. We used to take opposite resistance. So automatically this R1 plus J XC1 into ZX will be R2 into R4. This is the equation. This option C is correct because Z1 equal to R1 parallel J omega C1. So admittance value is this. Z2 is equal to R2. We know that Z4 value is equal to R4. So ZX is unknown impedance because Z1 and ZX is Z3 will be of a impedance because these two are Z1 is impedance, automatically Z3 is here denoted as a ZX. ZX is also a impedance. We know for balanced condition Z2 Z4 equal to Z1 Z3. Z3 is nothing but ZX. So I can put ZX by Y1. So ZX value will be Z2 Z4 Y1. So ZX equal to Rx plus J omega Lx. This will be R2, R4 into 1 by R1 plus J omega C1. By solving all these things, we will get this. So it will be to compensate the capacitance effect automatically in the bridge circuit, you are using the inductance effect. That inductance effect is low quality factor inductance That's because of the application here. Okay, good. Thank you, Bashir, for the response. Can you understand this, students? Can all of you understand this? In the questions, you should not take, for this questions, you should not take much time. Within a second, you can answer for these questions because this is a simple repeated bridge circuit questions only. So you can get the answer within a minute. Okay. Shall I move to next question? Shall I move to next question? Say yes or no. Shall I move? Yes. Next question. See here. A 4.5 digit. A 4.5 digit digital multimeter. DMM. Digital multimeter has the error specification as 0.2 percentage of reading plus 10 count. 0.2 percentage of reading plus 10 counts. If a DC voltage of 100 volt is read on its 200 volt full scale, if a DC voltage of 100 volt is read on its 200 volt full scale, the maximum error that can be expected in the reading is, the maximum error that can be expected in the reading is option A 0. Plus or minus 0.1 percentage, option B plus or minus 0.2 percentage, option C plus or minus 0.3 percentage, option D plus or minus 0.4 percentage. The answer is, we have to get the error calculated. From the given data, we can write 4.5 digit display will read from 000.002 199.99. So error of 10 counts is equal to plus or minus 0.1 volt. So error of 10 counts is equal to plus or minus 0.10 volt. For 100 volt, I am considering to here the measurement value should be of 100 volt. அவங்க என்ன சொல்றாங்க 4.5 digit display அப்படின்னா it will read from 000.002 to 199.99. So error of 10 count will be of plus or minus 0.1 percentage. So for 100 volt, the maximum error is, you know, the error formula E is equal to plus or minus the error percentage plus the available error. So 100 into 0.002 plus 0.1. So answer will be of plus or minus 0.3 volt. The answer is option C. The answer is option. The answer is option C. Okay. Plus or minus 0.3 percentage of the reading will be calculated. Will be of error. Percentage of error will be of 0. Plus or minus 0.3 percentage of reading. Okay. Next. For this question also, you will tell the answer within a minute. A wattmeter is connected as shown in figure. A wattmeter is connected as shown in figure. The wattmeter reads option A 0 always, option B total power consumed by Z1 and Z2, option C power consumed by Z1, option D power consumed by Z2. What's the answer? You can say the answer within a minute. A wattmeter is connected as shown in figure. A wattmeter read number 1 option 0 always, option 2 total power consumed by Z1 and Z2, option C power consumed by Z1, option D power consumed by Z2. Can anyone answer this question? Can anyone answer this question? You can tell the answer within a minute. You can tell the answer within a minute, ma. What's the answer? Just try it, ma. Can anyone just try it? Just try it. What's the answer? Yes, very good. The answer is option D. Option D. It's the correct answer. Bashit, can you justify your answer? Bashit, can you justify? Can you justify your answer, ma? Answer is option D. It's the right answer. Can you justify your answer? Just unmute your mic and say the answer, ma. Justify your answer. Your answer is somewhat correct. Current through potential coil will be very less. Okay. Somewhat your answer is correct because the potential coil is connected across the Z2, not across Z1. So current coil can measure the current of both Z1 and Z2, but a potential coil can measure the voltage of Z2 only. So we can calculate the power of Z2 only because the current coil can measure the current of both Z1 and Z2, but the potential coil can measure the voltage of Z2 only. So to calculate the power, we need both potential as well as, yes, good, Z1 and Z2 current both are same because current coil can measure same current, Z1 and Z2, but the potential is connected across only Z2. Correct down. Z1 Z2 carry same current. Z1 and Z2 carry same current. That is correct. But the potential is measured across Z2 only. It is not measured across Z1. The potential value is measured across Z2 only. So for Z2 only, I am having both current and voltage value. If I have both current and voltage value, then I can calculate the power value. So the power value, power consumed by Z2 only can calculated using this circuit configuration. If this potential coil is connected across Z1, then the answer will be, if the potential coil is connected across Z1, consider if this potential coil is disconnected here and connected to this point, connected here, then what is the answer? Then what is the answer? No. If connected across both, then answer is. If it is disconnecting here and connecting across here, then the answer will be disconnected from Z2. Yes, it is answer option C. If it is connected across Z1, then the answer is option C. You have to understand. Okay, good, ma, good, very good. Here the answer is option D because the potential coil is connected across Z2 only. The potential coil is connected across Z2 only. So the Z2 impedance, for Z2 impedance only, the current and voltage value is calculated. So the power consumed by Z2 only will be calculated. So the answer is option D. Good. Since the potential is applied across Z2, we can calculate the wattmeter read power consumed by Z2. That is the answer. I am moving on to the next question. Okay. I am moving on to the next question. An ammeter has a current range of 0 to 5 ampere. An ammeter has a current range of 0 to 5 ampere. And its internal resistance is 0.2 ohm. And its internal resistance is 0.2 ohm. In order to change the range of the ammeter from 0 to 25 ampere, in order to change the range of the ammeter from 0 to 25 ampere, we need to add the resistance of options. Option A 0.8 ohm in series with meter. Option B 1.0 ohm in series with the meter. Option C 0.04 ohm in parallel with the meter. Option D 0.05 ohm in parallel with the meter. Okay. Okay, I'm asking you people one question. In order to change the range to 0 to 25 meter, whether I need to add the resistance in series or parallel. Whether I need to add the resistance in series or parallel in order to increase the range, in order to change the range, whether I need to add the resistance in series or parallel. Whether I need to add the resistance in series or parallel, ma? Yeah, an ammeter has a current range of 0 to 5 ampere and its internal resistance is 0.2 ohm. In order to change the range to 0 to 25 ampere, we need to add a resistance. The resistance must be added in series or parallel. I am asking you to increase the range, to change the range, whether the resistance must be added in series or parallel. Respond, ma. Whether the resistance must be added in series or parallel. You have to give the justification. Whether we need to add the resistance in series or parallel. Yes, Vivek, Satish, Bashid, Bharat, Gomadinathan, Gayatri, just try it, ma. Just try it. Yes, it has to be connected in parallel. I agree. But you have to give the justification. Why we have to connect it in parallel, not in series? In series circuit, current is because overall resistance becomes low, which allows more current to flow through. Yeah, that's one of the point. Good, very good. That is one of the justification. But usually, we know if I'm connecting the resistance in series with the given resistance means, if I'm connecting in series now, we know the series circuit current is same. In the series circuit, the current value does not change. We know that. In the series circuit, the current value doesn't change. So, if I want to change the current value, current range, I need to add the resistance in parallel. Okay, if I want to change the voltage value, then I will go for, if I want to change the voltage range, then I will go for the, if I want to change the voltage range, then I will connect the resistance in series. Yes, that's the difference. That's the simple logic. If I am connecting the resistance in series now, the series resistances can have the same current, so we cannot vary the range. If I want to vary the range of current, I have to add the resistance in parallel. If I want to change the range of the voltage, I have to add the resistance in series. That is the difference. So I am calculating, I am connecting the resistance in parallel. So parallel resistance value I am taking as a RSH. So I am connecting it as a parallel. This 0.2 ohm resistance has a range of 5 ampere. This parallel resistance can have a total current is 25 ampere. This 0.2 ohm resistance can carry a current of 5 ampere. If the current value is 20 ampere, what is the value of the resistance? These two resistance are connected in parallel, so the voltage across both the resistance will be same. So 20 into RSH is equal to 5 into 0.2. Can we put like this? So 20 into RSH is equal to 5 into 0.2. So by solving this, I will get RSH is equal to 0.05 ohm. So the answer is option D. We have to connect 0.05 ohm resistance in parallel with the ammeter. Okay. Can you understand this? Can you understand this? Is everybody understood this? Say yes or no. Is everyone understood this? Yes, fine. Okay. This is one of the error calculation. Just try it this. Just try this. I am reading the question. You have to try the answer. Okay. As shown in figure, the negative feedback system has an amplifier gain 100 with plus or minus 10% tolerance in the forward path, and the attenuator of a value 9/100 in the feedback path. The overall system gain. How to calculate the overall gain? Use the control system formula. What is the formula for overall gain? What's the formula for gain? What is the formula for gain? What's the formula for gain? Gain equal to G of S divided by. What's the formula for gain? Just try it. Calculate the gain. This is a simple application of control system only. What's the formula for gain? We know from the control system, the formula for overall gain of the system is G gain A equal to G of S divided by 1 plus G of S H of S. Here G of S value is equal to 100 plus or minus 10%. The H of S value is 9/100. This 100 plus or minus 10% is including the error. The G of S value is 100. The G of S value is 100 with no error. With no error, the G of S value is 100. So the gain value G is equal to 100 divided by 1 plus 100 into 9/100. Can you get this point? The gain formula from control system is G of S divided by 1 plus G of S H of S, right? Gain equal to G of S divided by 1 plus G of S H of S. Here G of S value given is 100 plus or minus 10%. Thus that plus or minus 10% is nothing but the error value. That plus or minus 10% is nothing but the error value. So the overall gain of the system G is equal to 100 divided by 1 plus 100 into 9 by 100. By giving this G is equal to gain value is 10. If I am having the error of plus 10%, then the gain value is 10.0.91. Okay, 10.091. If I am considering a negative error, negative minus 10%, the gain value is 9.89. So the automatically the error value will be 10 plus or minus 0.1. Either it will be of plus 0.1 or it will be of minus 0.1. So the gain varies from 10 plus or minus 1 plus or minus 0.1. This 0.1 is nothing but 1%. Can you get this? Can you get this? Say yes or no. Can you get this? Is this understandable? Is this problem understandable? The answer is the answer is option A. Just gain formula using control system. Gain value is equal to 1 plus G of S divided by G of S divided by 1 plus G of S H of S. I am substituting G of S and H of S value. With I am considering three categories: 0 error, plus 10% error, and minus 10% error. By considering all these three categories, the error is varies from plus or minus 1%. That is the answer. Can you get this? Can you get this? Just respond, ma. Can you get this or not? Okay. I'm moving to next question. The next question is shown in figure. The Maxwell bridge shown in figure is at balance. The parameters of inductive coils are R plus J omega L, R3, R2, and R4 minus J by omega C4. We have to find the value of inductive coil. We have to find the value of L. We have to find the value of L. இப்போ L value find question கேட்டிருக்காங்க, the parameters of inductive coil னு கேட்டிருக்காங்க. அப்ப ஆட்டோமேட்டிக்கா ஆப்ஷன் எந்த ஆப்ஷன்ஸ் தான் வரும்? ஆட்டோமேட்டிக்கா ஆப்ஷன்ஸ் எந்த ஆப்ஷன்ஸ் தான் வரும்? எதெல்லாம் ஆன்சரா வரதுக்கு சான்சஸ் இருக்கு? What will be the choices of answer? We can neglect from the choices. We have to find the value of parameters of inductive coil. We can neglect the options. What are the options we can neglect? Okay. I'm just having the balance condition. Balance condition, we know that R1, R4 and R2, R3. R1, R4 equal to R2 and R3. That is the balance condition. So R1 is equal to R plus J omega L and R4 is equal to R4 parallel minus J by omega C4, which is equal to R2, R3. By solving this equation, I will get L is equal to R2, R3, C4. L is equal to R2, R3, C4. This L value is equal to R2, R3, C4 is the answer. That is option A. Our answer is just option A. We are doing nothing here. We are just taking the balanced bridge condition. Balanced bridge condition. I am taking balanced bridge condition R1, R4 equal to R2, R3. I am taking the condition and solving the equation. I will get the answer. That is option A. Okay. The next question. The next question. The pressure coil of the dynamometer type wattmeter. The pressure coil of the dynamometer type wattmeter always highly resistive. We know that the potential coil of dynamo type wattmeter is will be of always it is highly resistive. Okay. Next also. This is also a simple question. The two inputs of a CRO are fed with two stationary periodic signals. The two inputs of a CRO are fed with two stationary periodic signals. In the XY mode, the screen shows a figure which changes from ellipse to circle and backs to ellipse with its major axis changing orientation slowly and repeatedly. The following inferences can be made from this. What are the inferences made from this is, number one, the signals are not sinusoidal. Number two, the amplitude of the signals are very close but not equal. The third inference may be, the signals are sinusoidal with their frequencies very close but not equal. The fourth option is, there is a constant but small phase difference between the signal. There is a constant but small phase difference between the signals. Okay. The two inputs of the CRO are fed with two stationary periodic signals. In the XY mode, the screen shows a figure which changes from ellipse to circle and backs to ellipse with its major axis changing orientation slowly and repeatedly. The following inferences can be made from this. What will be the answer? The signals are not sinusoidal. The amplitudes of the signals are very close but not equal. The signals are sinusoidal with their frequencies very close but not equal. There is a constant but small phase difference between the signal. If the CRO output changes from ellipse to circle and back to ellipse, if ellipse to circle as well as back to ellipse means it always be a constant phase difference. That is option D. If it changes repeatedly, slowly and repeatedly, if it changes slowly and repeatedly from one ellipse to circle as well as circle to ellipse, then automatically there is a constant phase difference, but it is a small phase difference. So the answer will be option D. Answer is option D. This is the observation from the CRO, cathode oscilloscope out. Okay. The next one is, for this also you can get the answer within a minute. Okay. The figure shows three-phase delta connected load. A figure shows three-phase delta connected load supplied from a 400 volt 50 Hz three-phase balanced source. A figure shows a three-phase delta connected load supplied from a 400 volt 50 Hz three-phase balanced source. The pressure coil and current coil of a wattmeter are connected to the load as shown in figure. The pressure coil and current coil of a wattmeter are connected to the load as shown in figure. With the coil polarities suitably selected to ensure a positive deflection, the wattmeter reading will be, the wattmeter is connected across what is the value of potential coil? What is the value of potential coil here? What is the value of potential coil? The voltage measured by potential coil is, can anyone say what is the value of potential measured by potential coil? What is the value of voltage measured by potential coil? Can anyone say what is the value of voltage measured by potential coil? The voltage across The potential measured VBC. VBC. It is the voltage measured by a potential coil. What's the current measured by potential current coil? What's the current measured by current coil? The voltage measured by potential coil is VBC because potential coil is connected across the terminal BC. So the value is VBC. What's the value of current measured by current coil? What is the value of current measured by current coil? What is the value of current measured by current coil? What is the value of current measured by current coil? Current coil is connected between the terminal A and C. The current value will be IAC, right? The current value will be IAC. So I am calculating the potential coil and current coil. The potential coil, the potential value is for VPC equal to VBC equal to 400 angle of minus 120 degree. The current value is 400 angle of 120 degree. 400 angle of 120 degree. The voltage, the impedance value at the terminal AC. The impedance value at the terminal AC is 100 plus J0. 100 plus J0 can be written as 100. So the current value will be ICC equal to IAC equal to 4 angle of 120 degree. Now I have the value of voltage as well as current. So the power value P is equal to VI. Substituting voltage and current value, I will get, by substituting voltage and current value, I will get power value P is equal to 1600 angle of 240 degree. This 1600 into angle of 240 degree will be equal to 800 watt. Will be equal to 800 watt. By converting this into a rectangular form, it will be of 800 plus J0. It will get the answer of 800 plus J0. By converting this polar into rectangular, you will get 800 plus J0. So automatically the answer will be of 800 watt. Can you get my point? Can you get my point, students? Can you get my point? Say yes or no. Do you know how to solve this? Can you understand how to get the answer for this problem? Can you understand how to get the answer for this problem? Can you understand how to get the answer for this problem? Huh? Just I am calculating the value of voltage and calculating the value of current. The product of voltage and current will given as a power. Simple V and I calculations only. The next problem. The next problem is the average reading digital voltmeter reads 10 volt when fed with the triangular wave. An average reading digital multimeter reads 10 volt when fed with the triangular wave, and it is symmetric about time axis. For the same input, an RMS reading meter will read. For the same input, an RMS reading meter will read. The answer is average value of a triangular wave. The average value of a triangular wave, V average equal to Vm by 3. The average value will be Vm by 3 because it's a triangular wave. If it is normal sinusoidal wave, we can put it as a Vm by. If it is normal sinusoidal wave, then the average value is V average equal to Vm by Vrms equal to Vm by. For normal sinusoidal wave, Vrms value equal to Vm by. For sinusoidal value, Vrms value will be equal to. For sinusoidal value, Vrms value will be equal to. So the average value of a triangular wave, V average equal to Vm by 3. The RMS value of a triangular wave, Vrms equal to Vm by root 3. If it is sinusoidal wave, then it is Vm by root 2. You know that. So V average equal to Vm by 3. Vrms equal to Vm by root 3. So Vm by root 3 equal to root 3 into V average. It gives a V average of 10. So 10 root 3 volt. This is the answer. So the answer value is option D, 10 into root 3. Answer is option D, 10 into root 3. The next is two 8-bit ADCs. Two 8-bit ADCs. One of the single slope, one ADC is of single slope integrating type and the other of successive approximation type. One ADC of single slope integrating type and the other ADC of successive approximate type. The two ADCs take time TA and TB to convert 5-volt analog input signal to equivalent digital output. If the input analog signal is reduced to 2.5 volt, the approximate time taken by two ADC will respectively be. The option is answer A because the conversion time does not depend on the input voltage. Keep that in mind. This is one of the important observation. This is one of the important observation in analog to digital conversion techniques. In the analog to digital conversion technique, the conversion time does not depend on the input voltage. The conversion time does not depend on input voltage. So if the input voltage varies, the conversion time does not vary. Even though the input voltage varies, the conversion time doesn't change. Can you understand? In the analog to digital conversion technique, the conversion time does not depend on the input voltage. Even though the voltage varies, the conversion time doesn't change. Keep this in mind. Keep this in mind. So the answer is option A because the same conversion time. The conversion time does not change. The answer is option A. Okay. The answer is option A. The next one is two sinusoidal signals. One is P omega 1 comma t equal to A sin omega 1 t and Q of omega 2 t are applied to X and Y inputs of dual channel CRO. The X and Y inputs of a dual channel CRO. The Lissajous figure displayed on the screen shown below. The Lissajous figure displayed on the screen shown below. The signal Q omega 2t will be represented. The signal Q of omega 2t will be represented as, see, this is the observation figure. This is the observation figure. In the observation figure, the frequency ratio Fi and Fx equal to meeting points of horizontal tangents divided by meeting points of vertical tangents. In horizontal tangents, it meets at 2 points. In horizontal tangents, it meets at 2 points. So it is 2. In vertical, it meets at 4 points. In horizontal, it meets at 2 points. In vertical, it meets at 4 points. So Fy divided by Fx equal to 2 by 4. So Fy equal to 1 by 2 into Fx. The fx value is omega 1. The fx value is omega 1. So omega 2 equal to omega 1 by 2. Omega 2 equal to omega 1 by 2. Omega 2 equal to omega 1 by 2. So the Lissajous figures are ellipse. So the Lissajous figures are ellipse. So there's a phase difference of 90-degree exists between vertical and horizontal inputs. So automatically the answer will be Q of omega 2t equal to A cos omega 2t. This 90-degree, so it 90-degree phase difference exists. So I am putting cos omega 2t here. The P of t is P of omega 1t is sine. Then due to 90-degree phase shift, I am using here as a cos. You have to know the difference. So Q of omega 2 equal to A cos omega 2t. Omega 2 value is equal to omega 1 by 2. This is the answer. Okay. The next one. Have you understood this problem? Have you understood this problem? This is simple logic. This is a simple logic between two horizontal and vertical tangents. Have you understood? Shall I move to next question? Within that, we can wind up the session. Have you understood this problem? Have you understood? Have you understood this problem? Shall I move to next one? Within this, within that, we can wind up the session. Shall I move to next question? No response. No one is listening. How can I take this? Nobody is listening. How can I take this? Okay. I'm moving to next question. The AC bridge shown in the figure is used to measure the impedance. The AC bridge shown in figure is used to measure the impedance. Z. I have to measure the value of impedance Z. If the bridge is balanced for oscillator frequency F is equal to 2 kHz, then the impedance Z value will be, for balancing condition, I will put Z1, Z3 equal to Z2, Z4. So I will take this as a ZAB, ZBC, ZAD. So to balance the bridge, ZABCD into ZAB into ZCD equal to ZAD into ZBC. ZAB value, this ABCD, ZAB value will be 500, ZCD value is ZAD value is 200J plus 30, right? 200J plus 300. The ZBC value is minus 200J plus 300. By solving this, Z is equal to 260 plus J0. This is the answer. 260 plus J0. The answer is option A. The answer is option A. The answer is option A. To calculate the impedance value only, here they are giving the frequency. Here inductance and capacitance value, L and C value is given here. To calculate the XL and XC value, the frequency value will be taken as a 2 kHz. Keep that in mind. Here the impedance value given in terms of inductance and capacitance. We have to convert this L and C in terms of into XL and XC. To calculate the value of XL and XC, we are using the frequency value of 2 kHz. By solving this, I am taking this as a ABCD A. From this ABCD A, this is 500 ohm. I am starting from this ABCD A. D. A, B, C, D, A. From this AB value is 500, BC value is 300 plus that frequency value 1 by J omega L, J omega C, 1 by J omega C. Is that AD value also here? By substituting all the values, we can get the value of Z. Is that clear? Is this clear? Is this clear, ma? Is this clear? Have you understood? Have you understood all the problems I have taught today? Have you understood all the problems I have taught today?